Hi children, today you are going to learn 10th class 9th chapter, that is tangent and secant circle in that exercise number 9.2. Already in the 9.1 we have discussed about the theorem, that is the length of tangents drawn from an external point to a circle are equal. The length of tangents, the tangents which we draw from the external point to a circle are equal. This is what the theorem already we have explained in the exercise number 1 video in the previous video. Let us see once again, because based on this content we have exercise number 2, some of the problems. So here PA and PB are the two tangents from the external point P to the circle O with the center O, and here OA and OB are the radius which are always perpendicular to the point of contact. Remember, the radius is always perpendicular to a point of contact. Now here 90 degrees and 90 degrees. Let us take the two triangles here, triangle AOP and triangle BOP. Those triangles are known as right angular triangles. So in triangle AOP, here 90 degrees, angle A equal to 90 degrees. In triangle BOP, angle B equal to 90 degrees. AOP and BOP equal to 90 degrees and 90 degrees. Here OP is a common hypotenuse for both these triangles. 90 degrees opposite side is known as a hypotenuse. So OP is a hypotenuse for AOP triangle and BOP triangle. And here OA and OB are equal radius, nothing but its sides. So right angle hypotenuse sides. By the RHS rule, this triangle AOP and BOP are congruent. By the CPCT rule, corresponding parts of congruent triangles. CPCT in the sense, corresponding parts of congruent triangles. By that rule, the remaining corresponding sides PA and PB are also equal. Hence, we can conclude that the length of tangents, this length of tangents which are drawn from an external point to a circle are always equal. And this is a theorem which will help us to complete the sum of the problems in this exercise. Now here there are some choose the correct questions are given, and we need to give a particular answer for these questions also. We have to justify the answers. So see that the first question, the angle between a tangent to a circle and the radius drawn at the point of contact, the angle between radius to the circle, the tangent to a circle, okay, and the angle between the tangent to a circle and to the radius. This angle will be always perpendicular. Now you need to write that the radius is always perpendicular to the point of contact. Here I will write the justification. The radius is always perpendicular, nothing but 90 degrees, to the point of contact. So where is the option now? Here the option D comes in. Next the question is, next question, from a point Q, the length of tangent to a circle is 24 cm. From a point Q, let us take a point Q here to the circle O, the length of tangent here, the length of tangent is 24 cm. Suppose it is A, there is a point of contact is A. So the length of tangent is 24 cm, and the distance from Q from the center of the circle, from the center, is 25 cm. The distance from Q to center, it is 25 cm. Then what is left? This is the radius. Now we need to find out. Then radius of the circle is dash. What should be the radius? R we need to find out. Here we know that it is a 90 degrees. In triangle AOQ, where angle A equal to 90 degrees, we know that the radius is always perpendicular to the point of contact. By using Pythagoras theorem, by using Pythagoras theorem, by using Pythagoras theorem, we can say that OQ square equal OA square plus AQ square or QA square. Here OA square we need to find the radius. So QA square will transfer this side. OQ square minus QA square equal to OA square. This square also will transfer the other side. That becomes a square root. So OA equal to square root of OQ square minus QA square. Let us substitute the values that OQ is a 25 whole square minus QA, that is 24 whole square. OA equal to under root of 25 into 25, that is 25 square, that is 625 minus 24 square, 24 into 24, 576. Then you find the difference between these, you get, that is like 49. The distance, the difference between the 625 and 576 is 49. Under root of 49 value is 7 centimeters. Then your OA is nothing but a radius of the circle. The radius of the circle is 7 centimeters. There is a 7 centimeter in this. The option is 8. So this justification has to be right. So before, if you want to prove that, justification should write like this. Now here the third question. If AP and AQ are the two tangents to a circle with the center O. Yes, AP and AQ are the two tangents which we have drawn from the external point A. We know that these two tangents are so equal, that you remember. But here so that angle QOP, angle QOP, Q to O, O to P, the angle is given 110 degrees. Then angle PAQ is equal to PAQ. Here the angle. What angle should come at the angle PAQ? That's very simple here. We know that the radius is perpendicular to, we know that the radius is perpendicular to point of contact. So here it is 90 degrees and here also it will be equal to 90 degrees. So angle OPA is equal to angle OQA is equal to 90 degrees. OPA and OQA is equal to 90 degrees and 90 degrees. Hence, now if you see clearly here, APOQ is a quadrilateral. Here APOQ is a quadrilateral. Sum of four interior angles of a quadrilateral will give us 360 degrees. Yes, the sum of four interior angles of a quadrilateral, any quadrilateral, is equal to 360 degrees. So here angle P plus, angle O plus, angle Q plus, angle A equal to 360 degrees. Angle P is 90 degrees, angle O is given 110 degrees, angle Q is 90 degrees, angle A is nothing but angle PAQ, that is what we need. Angle PAQ, that is equal to 360 degrees. Let us add this all this, 90 plus 90, that is 180, and 190 and 290. The sum of this is 290 degrees plus angle PAQ equal to 360 degrees. So this 290 degrees will transfer the other side, so that we get angle PAQ is equal to 360 degrees minus 290 degrees. So angle PAQ is equal to, that will be a 70 degrees. So the option we got, I think so, where is the 70 degrees option here? That is option B. Option B. I hope you understood this explanation. See once clearly. Now this is the fourth question, which is similar to the previous question only. See that if tangents PA and PB is set, so the PA and PB are two tangents. Let us draw here. PA is a one tangent, PB is another tangent. PA and PB are the two tangents. Okay, from a point P to a circle with a center O. So PA and PB are two tangents from point P to the circle O, are inclined to each other at the angle of 80 degrees. ఈ PA tangent PP tangent అనేవి angle 80 degrees దగ్గర బాండ్ అయి ఉన్నాయంట. It is bonded with the angle of 80 degrees. This PA and PB tangents made 80 degrees angle at the point of P. Then what is the angle of POA? So if you join here, yes, this is if you draw a bisector, of angle of 80 degrees, it become a 40 degrees and 40 degrees. See, now we have to find out angle POA here. What angle should come? Now already we know that this is a 90 degrees angle. So here let us draw the bisector OP. Bisector. Then what happens? See, OP bisector, if you draw the angle APO, then the angle APO become a 40 degrees. It is 40 degrees. It is 40 degrees. Okay. Then APO and we will write BPO equal to 40 degrees. కానీ మనకి APO నే కావాలి, ఇది కావాలి. Okay. Then we know that the radius is perpendicular to the point of contact. And we also know that we also know that the radius of the circle is perpendicular to the point of contact. So here angle OAP. So angle OAP is equal to 90 degrees. Now here 90 degrees is 40 degrees. 90 and 40. Now in triangle, now we'll take in triangle AOP. Angle A equal to 90 degrees. We don't require Pythagoras theorem. We need this angle, no? So sum of three angles equal to 180 degrees. Sum of three interior angles. Sum of three interior angles of a triangle is equal to 180 degrees. What are the three interior angles? Angle A plus angle POA plus angle P. That means here What are the angle here? 90 degrees plus here 40 degrees plus this angle POA. Angle POA is equal to 180 degrees. 90 degrees plus 40 degrees, that is 130 degrees plus angle POA equal to 180 degrees. This 130 degrees will transfer the other side. Angle POA equal to 180 degrees minus 130 degrees. Then angle POA will give us 180 minus 130 is 50 degrees. 50 degrees. Where is the 50 degrees in the option? Here. So that is option A. So I hope you understood this explanation. See, for every bit there should be explanation. Now here the fifth question. See that in the given figure, in this figure, xy and x dash y dash are two parallel tangent to a circle. Okay, to a parallel tangent to a circle. So here xy is a one tangent, x dash y dash is a another tangent. X dash is a one tangent and x dash y dash is an another tangent. If those tangents are called parallel tangents. Yes, that is what in the given figure xy and x dash y dash are two parallel tangents to this circle with the center O. Yes, we have with the center O. And another tangent AB. Yes, here there is another tangent AB. See, A and B is another tangent with the point of contact C. Yes, this tangent is contacting at C and intersecting xy at A and x dash y dash at B. See, this another tangent AB is intersecting xy tangent at the point of A and x dash y dash tangent at the point of B. Then find angle BOA. Angle BOA. This angle we need to find. This angle we need to find. Now, if you observe very clearly here, one thing we can say. What? See that these two parallel tangents, and here xy given that xy is parallel to x dash y dash are two parallel tangents, and xy is a tangent. Xy is a tangent. It intersecting x dash AB. AB is a tangent. It intersecting xy at A and x dash y dash at B. Perpendicularly they will be intersecting because these two are the parallel lines and it is also a tangent. A tangent will give a straight line here. So here AB is a tangent. It is intersecting xy at A and x dash y dash at B perpendicularly. This perpendicularly they are not mentioned in the question. That we have to know it. So we can say that it is a 90 degrees. Here it is a 90 degrees. So angle CAX is equal to angle CBX dash. Angle CBX dash equal to 90 degrees. But here OB and OA are bisectors of angle CAX and CBX. But here OA and OB are two bisectors of angle CAX and angle CBX. So we get here If it is bisector angle, 45 degrees and 45 degrees. It is 45 degrees and 45 degrees. So we get angle OAB. So we get angle OAB, which is equal to angle OBA, angle OBA, which is equal to 45 degrees. Now, if you observe a triangle, AOB triangle, if you observe a AOB triangle and triangle AOB, sum of these three interior angles, 1, 2, 3, sum of three interior angles is equal to 180 degrees. Sum of three interior angles is equal to 180 degrees. What are the three interior angles here? Angle AOB, OAB and OBA, and here angle OAB plus angle OBA plus angle AOB, that equal to 180 degrees. Here OAB plus OBA, 45 and 45. This is 45 degrees plus this is 45 degrees. These two angles 45 and 45. And this angle we need to find, that is angle AOB is equal to or BOA. BOA and AOB and okate kada. We will write as a BOA because in the question he asked BOA. The question they asked BOA. So 45 plus 45 plus angle BOA equal to 180 degrees. 45 plus 45, that is 90 degrees plus angle BOA equal to 180 degrees. This plus 90 degrees will transfer the other side. So angle BOA equal to 180 degrees minus 90 degrees. That is angle BOA equal to 90 degrees. So it should come here 90 degrees. Or else the other process. See that here is 45 degrees now. Here also will be 45 because these two lines are parallel lines. Okay. Then this will be, here we get one more parallel. This two will be, see, these two will be parallel lines. Ikkada rendu kuda parallel anukochu. AB will be parallel to this line. This alternative angles will be equal and this alternative angles will be equal. So here 45 degrees. So here 45. Here 45 degrees. So here also 45. 45 and 45, 90. So more 90 degrees we required to make it 180 degrees because it is a straight line. Diameter is in a straight line. So in that way you can do it, or not this process you can do it. With this we have completed this multiple choice questions. You can see here the option C. Option C is 90 degrees. There you write the option C, that is 90 degrees. Now we go for the question number 2. Here question number 2, please look at your textbook. Two concentric circles. What is meaning of concentric circles? If two or more than two circles, if they have common center point, and those circles are known as concentric circles. See, these all the circles having same center point, then these circles are known as concentric circles. If two or more than two circles having same center point, those circles are known as concentric circles. Two concentric circles of radius 5 cm and 3 cm. This is, suppose with the radius it is a 3 cm here. Okay. Then suppose this is a radius with a 5 cm. We have a inner radius is a 3 cm and outer radius is a 5 cm. And see, find the length of chord of larger circle. Length of chord of larger circle which touches the smaller circle. Okay, chord draw cheyali. What is meaning of a chord? A line segment which intersects the circumference of circle at two end point and which is not passed through the center point of the circle. Yes, chord ikkada undi kada, chord ku join cheyandi. Yes, that is all. And see, and this is a chord. What here AB is a chord, suppose, and this is a point C. and it is a O, suppose O is the center of the circle. O is a center of the circle. Now let me write here AB is a chord of the larger circle. Here O is a center of two circles, nothing but a concentric circles. Of OC is a inner radius. OC is a radius of smaller circle. Here OB is a radius of larger circle. Here OC is a bisector of AB. OC is a perpendicular bisector. OC is a perpendicular bisector of AB chord. Perpendicular bisector in the sense where AC is equal to BC. Where AC will be equal to BC. This we need to be remembered. When AC is equal to BC. Here OC is a perpendicular. Okay, the perpendicular which we have drawn from the center point of the circle will always bisect the chords. Okay, so this is what. Now if you see it is a perpendicular bisector, this it is 90 degrees. Now in triangle. Now in triangle BOC, in triangle BOC, angle C equal to 90 degrees. By using Pythagoras theorem, children, by using Pythagoras theorem, see two of the sides we know in this. We can find out the third side. So here by using Pythagoras theorem, what is the hypotenuse 90 degrees opposite side? That is OB. OB square is equal OC square plus BC square. Here BC square we need to find. If you know the BC, we can find out the AB. And we need to find out the length of chord only. AB we need to find. So AB find out చేయాలంటే BC తెలిస్తే మనకు AB తెలిసిపోతుంది. If BC is equal to AC కదా. BC is equal to AC. BC is 10, AC also will be 10. 10 plus 10 that AB, that is 20 like that. So this OC will transfer this side. OB square minus OC square, that equal to BC square. This square also will transfer this side, where BC equal to under root of OB square minus OC square. Where BC is equal to under root of OB, that is 5 centimeter, 5 square, 5 centimeter whole square, minus OC, that is 3 centimeter whole square. Hence the BC equal to under root of 5 square, that is 25 centimeter square, minus 3 square, that is 9 centimeter whole square. 25 centimeter square minus 9 centimeter square, that BC equal to under root of 16 centimeter square. Under root of 16 centimeter square is nothing but a plus or minus 4 centimeters. Plus or minus 4 centimeters. But we will take a place where BC equal to 4 centimeter. But where AB is equal to AC plus BC. AC plus BC. AC plus BC. That is AB. So here we know that here AC is equal to BC. AC will be equal to BC. So I can write here AB equal to, instead of AC I can write BC no. AC BC రెండు ఈక్వల్ కదా, instead of AC నేను BC అని రాస్తాను. BC plus BC, that equal to AB equal to 1 BC plus 1 BC, that 2 BC. Or not BC value substitute, BC equal to 4 centimeter plus 4 centimeter. That will be equal to AB equal to, that is 8 centimeter. Therefore the length of the chord, the length of the chord AB is equal to 8 centimeters. Length of the chord of AB equal to 8 centimeters. I hope you understood this clear. Let us go for the question number 3. Question number 3 now. Let us continue that question number 3. See that the question number 3 is here. Prove that the parallelogram circumscribing circle is a rhombus. The parallelogram circumscribing circle is a parallelogram. So let me write the question now here. Very simple. Prove that the parallelogram circumscribing అంటే parallelogram circle లో ఉన్నటువంటి parallelogram a circle circumscribing a circle is a rhombus మనం rhombus అని ప్రూవ్ చేయాలి circumscribing of a parallelogram circumscribing of a parallelogram we need to prove as a rhombus. Okay, let us prove it. See that circumscribing in the sense, okay, in a parallelogram there will be a circle. See that, suppose you draw a circle like this. Yes, let us go for a parallelogram. We will draw the parallelogram here. Yes, we will draw a parallelogram. Draw a parallelogram. Yes. Circumscribe of a parallelogram is a rhombus and prove cheyaali. Suppose let us take ABCD is a parallelogram. ABCD is a parallelogram. Here the parallelogram is circumscribed. So here let us write the PQRS. PQRS are the point of contacts. Okay, PQ, P comma, Q comma, R and S are point of contacts to a circle. Okay, then here we know that what we need to prove that we have to prove what we have to prove here, circumscribing parallelogram is a rhombus. We have to prove that it is a ABCD is a rhombus. ABCD is a rhombus. This is rhombus and prove cheyaali. Rhombus in the sense what? All the sides should be equal. AB should be equal to BC is equal to CD is equal to DA. This we have to prove it. If all the sides are equal, that is a rhombus. Then let us prove that. Let us go for proof. We know that here the tangents which we draw from the external point of the circle are equal in the length. The tangents which we draw from an external point to a circle are equal. So here we can write here AP and AS are these two are the tangents which we have drawn for this circle. This circle ku AP AS and two tangents. So we can write AP is equal to AS. This is equation number 1. Similarly, అదేవిధంగా మనం ఇంకొన్ని కూడా రాయొచ్చు. ఇఫ్ యూ అబ్జర్వ్ BP is equal to BQ. BP is equal to BQ. This is equation number 2. Then CR is equal to CQ. CR is equal to CQ. Equation number 3. And DR is equal to DS. DR is equal to DS. This all we are writing the basis on same theorem again. The tangents which we are drawn from the external points A, B, C, D are the external points of this circle with the center O, and we are drawing the tangents from the external points. They are always equal in the length. So we have written this. Adding equation 1 plus 2 plus 3 plus 4, we get, now by adding equation number 1, 2, 3, 4, equation number 1, comma 2 and 3 and 4, we get LHS sides. Let us add it. AP plus BP plus CR plus DR is equal to here AS plus BQ plus CQ plus DS. So here AB plus BP. Let us write as a one pair. Here CR plus DR. CR plus DR. We write in a one pair. Then again see that here AS plus DS. This AS and this DS. Let us write as a one pair. Plus here BQ plus CQ. These two will write as a one pair. BQ plus CQ. Then what happens? Here AP plus BP will give us AB. Here CR plus DR will give us CD. Here AS plus DS will give us AD. Plus here BQ plus CQ will give us BC. But ABCD is a parallelogram. So opposite sides are equal in parallelogram. Opposite sides are equal in parallelogram. So here AB equal to, we can write here, where AB equal to CD and BC equal to AD. BC equal to AD. We can write that. So here AB equal to CD. అంటే CD దగ్గర AB రాయొచ్చు కదా, because AB and CD అనేవి రెండు ఈక్వల్ గానే ఉంటాయి. సో AB equal to CD. That means this AB I will write as it is. Plus here CD I will write as again AB. This AD I will write as it is. And this BC I will write as again AD. So 2AB, AB plus AB, 2AB equal to AD plus AD, 2AD. 2 get cancelled, where AB equal to AD. AB equal to AD. That means this AB side is also equal to AD side distance. లేకుంటే మనము this CD side we can make equal to, also we can make it equal, this AB side is equal to BC side అని చేయొచ్చు. ఇక్కడ AB రెండు అలాగే వచ్చి దీన్ని BC గా మార్చుకొని BC plus BC 2BC, then we will also get here AB is equal to BC. So what happens? Already we know that opposite sides are equal and this adjacent sides also will be equal. Now what happened? AB equal to AD and this AB equal to BC kuda. AB equal to already CD. AB equal to CD because opposite sides are equal in parallel. Parallelogram ఈ రెండు sides already equal. This AB equal to CD and this AB is equal to AD and BC also. That means here AB is equal to BC is equal to CD is equal to AD. Now here AB is equal to BC is equal to CD is equal to DA. So the circumscribing the parallelogram circumscribing of a parallelogram is a rhombus. So the circumscribing Parallelogram is a rhombus. Write it therefore clearly. The circumscribing parallelogram is a rhombus. Now we go for the fourth question solution here. Already I have drawn a diagram of this fourth question. See that what we need to find out in this fourth question. A triangle ABC is drawn, circumscribe a circle of radius 3 centimeters. So the radius of this circle is 3 centimeter. This triangle is circumscribing on the radius of 3 centimeter, such that the segment BD and DC, which BC divided the point D, the point of contact D. So this D is a point of contact which is divided BC side. D is a point of contact which is divided this BC side, such that where BD equal to 9 centimeter and DC equal to 3 centimeter. The overall BC then, the BC side completely it is 12 centimeter. 9 centimeter plus 3 centimeter is 12 centimeters. The complete BC side is 12 centimeter. Then let's know that point of contact are the length of 9 centimeter and 3 centimeter respectively. Okay, find the sides of AB and AC. We have to find out this side AB and AC. Okay, where he is given that ABC, given that ABC is a triangle. If you observe, this triangle is a right angle triangle where angle C equal to 90 degrees. Angle C equal to 90 degrees. And where BD is equal to 9 centimeter and DC is equal to 3 centimeter. So where BC side is equal to 12 centimeters. So I will write this in another way. See. Now, B is a external point to the circle O. B is a external point to the circle O. So let me give you here A, B, C, D, E and F unknown points. E and F unknown points. So B is a external point. The tangents BD and BE are drawn from the external point B. The tangents BD and BE are drawn from an external point B. So we can write here BD is equal to BE is equal to 9 centimeters. Why they are 9 centimeters? Because the tangent which we drawn from the external points are equal in the sides. So now again here CD and CF, similarly CD and CF are drawn, the tangents CD and CF are tangents drawn from an external point C, such that where CD is equal to CF equal to 3 centimeter. CD is equal to CF is equal to 3 centimeters. So finished. Now let us assume where AE and AF, here AE and AF other two tangents which are equal in sides we know are drawn from the external point A. Here these 3 points AE and AF are two tangents drawn from an external point A to the circle. So we can assume here where AE and AF equal to x centimeters, where AE is equal to AF is equal to x centimeter, just assume or say అనుకోండి. అప్పుడు ఏమవుతుంది చూద్దాం. Now in triangle ABC, in triangle ABC, where angle C equal to 90 degrees, no? By using Pythagoras theorem, we can say that here AB square of the hypotenuse AB square is equal to BC square plus AC square. BC square plus AC square, where AB is nothing but this complete AB is 9 plus x centimeters, and this complete AC is 3 plus x centimeters. 3 centimeter plus x centimeter. 3 plus x, 9 centimeter plus x centimeter. 9 plus x. So all these three sides, BC also is the 12 centimeters, where AB is 9 plus x whole square, BC is a 12 centimeter whole square, plus AC 3 plus x centimeter whole square. It is in the form of like A plus B whole square. The formula equal to A plus A square plus 2AB plus B square. Let us change this. 9 square plus 2 into 9 into x plus x square, that equal to 12 square is 144 plus 3 square plus 2 into 3 into x plus x square. 9 square is 81 plus 2 9s are 18 into x, 18x plus x square equal to here 144 plus 3 square is 9 plus 2 3s are 6 into x, that is x square. On both the sides we can cancel the x squares. Plus x square we can cancel on both the sides, because if this plus x square, if you bring this side, that become a minus x square, no? However will cancel, so immediately I cancel. So the rest of things here, 81 plus 18x equal 144 plus 9 153 plus 6x. This 6x will bring this side and variables will one side and constant numbers will send one side. Variables are one side, constant numbers are one side. Here already 18x plus 6x become minus 6x, that equal to here 153 minus here plus 81 become minus 8. So 18x minus 6x, that is 12x equal to 3 minus 1 is 2. 15 minus here 15 minus 8 is 7. So here 12 is multiplying. If you transfer, that become a division. So 72 by 12. 12 5 is 60. 12 6 are 72. 12 1 are 12 6 are. X equal to 6. 6 is what? Centimeters. X is 6 centimeters. Then actually what we need to find? AB and AC. So the AB equal to, what's actually AB equal to 9 plus x centimeters. 9 plus x centimeters. Then AB equal to 9 plus, that is 6. Okay, centimeters. That equal to 9 plus 6, that is 15 centimeters. So we got AB equal to 15 centimeters. Again, AC we need to find out, where AC is a sum of 3 plus x centimeters, where AC equal to 3 plus x is 6 centimeters, that equal to 3 plus 6 is 9 centimeters. Therefore AC equal to 9 centimeters. I hope you understood this problem. I hope you understood this problem. If you want to take a screenshot, please take it. So only Pythagoras theorem I have applied. Here question number 5, question number 6 and question number 7. These three questions are constructions. How to construct the tangents. It's a very important questions. Question number 5, 6, 7 are very important questions. Those questions are constructions. Constructions will do a separate video on that. These three questions will do a separate video on the constructions. So next we go for the question number 8. 6, 7, 8, 5, 6, 7 will be explained a separate video of constructions. So you people continue the same answers, constructions, later you do it. Then you go for the question number 8 and question number 9. Those questions, 2 questions are there. Let us finish these 2 questions and complete this exercise. Now the question number 8. Here the question number 8. Let's see the question number 8 here. There is a diagram from this question number 8. I will draw the diagram. Wait. Now we go for this is the question number 8 and see that what is question number 8 will read now. In right triangle ABC, a circle with the side of AB is a diameter. In right triangle ABC. ABC is a right angle triangle where AB is a diameter. AB is a diameter. And triangle ABC, angle B equal to, we know that is 90 degrees, and AB is a diameter. Here he said that AB is a diameter. Again let us read the question. AB is a diameter. Are drawn intersecting the hypotenuse. So a circle with the side of AB as diameter and is drawn intersecting hypotenuse AC. Okay, intersecting hypotenuse AC at P. Okay, here this is AC is a hypotenuse. Angle B is a 90 now. If angle B is 90, then here AC is a hypotenuse and the hypotenuse one intersection point at P. One intersection point at P. Prove that the tangent to a circle P bisect the BC. Prove that the tangent to a circle P. The tangent to a circle P. This is the tangent. A circle P is bisect the BC. BC is bisect. Okay. AB is a diameter and AC is a hypotenuse. AC is a hypotenuse intersecting at the point Q. Intersecting at point P, point of P. And see that we need to prove that. To prove what we need to prove it here, we have to prove that intersecting is BC is bisected by P. BC is bisected by P. Prove that the tangent to a circle P is bisect the side BC. P is bisect the side BC. That means P is bisect the side BC in the sense. What is meaning of bisecting? That means dividing into equal parts. That means this PQ is bisected the BC position. PQ is bisected BC. That means here where bisecting BC in the sense this BC divided into two equal parts such that where BQ should be equal to QC. So that means we need to prove this where BQ is equal to QC. Even prove just the third. So let's go for the proof. Very small proof here. Already given that in figure, from the figure we can say that these two angles are equal. Then only has shown with the equal angles in the figure. That means in the figure these two angles are equal where angle P is equal to angle C. If angle P is equal to angle C, the sides which are opposite to the equal angles are equal. This is a theorem actually. ఈ రెండు angles equal గా ఈ రెండు sides కూడా equal ఉంటాయి. These two angles are equal, so the opposite sides are equal. This is the theorem. The sides which are opposite to the sides which are opposite to the equal angles are equal. So we can write here where PQ is equal to QC. Where PQ is equal to QC. This is equation number 1. Keep it like that. Then now we go for, when you observe here, O is the center of the circle. Here now, O is a center of the circle where Q is a external point. Q is a external point and PQ and BQ and PQ are the two tangents which we are drawn from the external point Q. Here PQ and BQ are two tangents which are drawn from an external point Q, an external point Q. So we know that from here, from Q నుంచి మనము B కు P కు రెండు tangents డ్రా చేస్తాం. The tangents which we draw from the external points are equal in length. We know that the tangents are drawn from an external point are equal in length. కనుక మనం ఏం రాయొచ్చు ఇక్కడ PQ is equal to BQ. PQ is equal to BQ. Now this is the equation number 2. So what I can say now here, this PQ is equal to QC, equation number 1 from 1 and 2. From 1 and 2 we can say that this PQ is equal to BQ. This PQ is equal to QC. From this both will take BQ is equal to QC. BQ equal to QC. PQ is equal to BQ. PQ is equal to QC. So we can say BQ equal to QC. If BQ equal to QC, we can say that P is bisected BC. And that means P is bisects to the side BC. Hence proved. This is what? Very simple. Yes. So చూడండి, ఈ రెండు యాంగిల్స్ ఈక్వల్ కనుక ఈ రెండు సైడ్స్ ఈక్వల్. ఇవి రెండు టాంజెంట్స్ ఎక్స్టర్నల్ పాయింట్ నుంచి డ్రా చేసాం కనుక ఇవి రెండు ఈక్వల్. దిస్ టూ సైడ్స్ ఆర్ ఈక్వల్, దిస్ టూ సైడ్స్ ఆర్ ఈక్వల్. దట్ మీన్స్ హియర్ BQ and QC ఆల్సో విల్ బి ఈక్వల్. హెన్స్ బైసెక్టర్ అయినట్టే కదా. ఆ రెండు ఈక్వల్ అని ప్రూవ్ చేస్తే మనం బైసెక్టర్ అంటాం. సో ఆ రెండు కూడా ఈక్వల్ అని ప్రూవ్ చేసాం. సో దే ఆర్ బైసెక్టర్. Then the last question of this exercise, that's very simple question. It's a very simple question. And see that question number 9. See that. Draw a tangent to a given circle. Draw a tangent to a given circle with the center O from a point R. Draw a tangent to a given circle with the center O from a point R. From a point R outside of the circle. So we have to draw a tangent to this circle, center O circle, from the outside of the point R. How many tangents can be drawn to the circle from a point, from this point? How many tangents we can draw? Only 2 tangents we can draw to a circle. Only 2 tangents we can draw to a circle. How many tangents we can draw to a circle to the external point of this circle. How many tangents we can draw from a external point of the circle? Only two tangents we can draw from an external point of the circle. From the external point of the circle. I hope you understood this. Exercise 9.2. The constructions from the 9.2 exercise we will discuss in the separate video. Till that time. Bye.